Good afternoon. How are you guys doing?
Afternoon.
Can you? Yeah. All right. So before we start today, welcome, Farah, Noel, and Kelvin. Okay. So on the screen you can see our Google Classroom. Please note that I've added this part under resources. Okay. You can see I've shared a guide, right? This guide is a short guide, okay, that tells you how you can redeem your token. Okay, so as before with FCN, this semester with computer networks, we will be using the Net Academy, Cisco Networking Academy, right, where you get all of your materials and also some practice. Okay, so if you follow our lecture and then after that you want to go through the materials on the Net Academy's website, it's actually quite rich in the sense that it has got some exercises, a quiz, yeah, that maybe can help you with your learning lah, right? So that means it's more details, right? And also you have some packet tracer configuration, yeah, some help there, right? So when we are going to do our practical at the end of this week, right? So when you're doing your homework, you can refer back to the materials that's provided online, right? So you you open up the PDF. Basically, you go to Cisco Net Academy, right? And on the upper right corner, you'll see something like this, yeah? The login, click on it, you'll see some options, right? Now, because you should still have your profile, okay? So just redeem seed token and enter the seed token that I provided in the Google Classroom, right? And you should enter your student info, right? This is not clock, this is click, that's clear, sorry, that's a typo. And here, right, currently have a Networking Academy login. I hope you still remember your password, yeah? You use the same profile as before. Okay, so it keeps track of your progression, okay, from FCN to this one, computer networks, excuse me, and then after that to advanced computer network, right? So use your email here, right? And then provide the seed token that I given to you, right? And that's it, right? Okay, so you should select this one. I currently have a Networking Academy login. So Noel, this is yours. Kelvin, that's yours. And Farah, that's yours, right? So when you go in, you will see under the materials, you'll see this, right? Where, as usual, we have all the materials for you to go through, right? And on top of that, if you still need to, this is my view, but you should have your own view for student view. You can go inside and look at the resources. Under resources, okay, you might have a slightly different view because it's student view. Okay, so it's already locked me out. Hang on, Okay, so I'm in. Once you're activated, once you go in, you should see the student viewer of the computer networks, right? So once you click the student resource, um, if you forgot about your packet tracer, you can click on this, okay? This following this, you don't have to go through everything. Just some parts where just to recall back what you learned on doing packet tracer, right? So if you have this to guide you, okay, to prepare for our work, because in this CN, the packet tracer, we assume that you still recall back all the what you can do. So we build up your knowledge, okay, what you have learned in intro to networks, computer networks, with some new commands. All right, some new commands that's related to what we are learning in this course. Right, packet tracer resource basically are just the same software. Let me see. Why is it not showing? Here. Oh, should be. Yeah, packet tracer resources. Should be the packet tracer 64-bit Windows, right? Oh, okay. I'm not sure why is this happening. Anyway, okay. Right. So let me just go back to this later. Then I can check. I can check. Yeah, I can check for you, and maybe you, I, I still can give you more tokens lah if the token is not successfully redeemed. All right. Okay. So I'm going to stop sharing here. All right. And share directly to our. Okay, I'm going to start recording also. We're gonna go through our second chapter, chapter 2. Right. So let me know if you can manage to register for our NetAcad. Yeah. Right. At the end of this week, I will activate the chapter exam for chapter 1. Okay, and maybe chapter 2 as well. Right. So this chapter 2, if you recall, we're going to divide it between this week and next week. Okay, it's a large chapter, right? If you go back to your classroom, hang on, and check the course plan. All right. So this is week 1, so we're going to start on chapter 2 VLANs, and then we continue again week 2 for the first lecture, chapter 2 VLANs, and then after that we're going to look at inter-VLAN routing. All right, so let's start today's lecture. Chapter 2, the equivalent to module 3, okay, VLANs or virtual LANs, right? And it's you will see that after you successfully um, redeem your token, you'll be, you know, be able to see the switching, routing, and wireless essential version 7, right? That is the module for CCNA that this course is mapped to, right? Okay. All right. So module title in the Net Academy is called Protocols and Models. All right. So the module objective in the Net Academy uh, is to explain, right, how network protocols enable devices. These are intermediate devices to access local and remote network resources, right? Remote network resources could be host, any kind of host, and devices or servers, things like that. Okay, right. So these are the topic titles within this chapter. We're going to look at virtual LANs, right? And what are their purpose? What is the purpose of having virtual LANs in a switch network, right? So why we specify switch network is because this is only achievable if your local area network are using switches, and switches, of course, will be the Cisco or equivalent to Cisco switches, where you can configure virtual LANs. Okay, the normal switch that you can purchase off the shelf that is quite cheap, right? The plug and play type will not have this feature. All right. Okay, so then we look at how virtual LANs act or use inside a multi-switch environment. So you have more than one switch, you connect switches together, right? Remember, we can extend or scale up our local area network by using switches. So having a one switch will give you a star topology, okay, with a switch in the middle, and it connects to all the hosts, right? So that topology is what we call star topology, right? When we extend that network, because we grow the network, we want to have more hosts, right? So basically, we add another switch and we connect the switch to the original switch. Therefore, we are creating an extended star network, right? So then when we have more than one switch, we are actually operating in a multi-switch environment, right? Right. So we will explain how the switch forward frames based on the virtual LAN configuration operating within a multi-switch environment, right? So after that, we're going to basically go into the practical side. Okay. How do we configure these multi-switches to be capable of virtual LAN? So we're going to look at virtual LAN configuration. It's not giving you the form. Did you click on the? You should. We go to network. So just log out first. Just pause my presentation first. Yeah.
Sorry, I try to.
Yeah. Go ahead. Go ahead. Show me your screen.
Yeah. So I click this, and then
Netacad.com. Yes. Login. Redeem seed token. Correct. Click on that.
and then it show me this screen.
Oh, you are already logged in. So can you go to Kelvin and log out first? All right. Okay. Let the Cisco single ID log you out. All right. So now do the same thing again.
Oh, okay, thanks.
Yeah. So should be able to continue. Yeah. Okay.
Okay,
So
thanks.
if you encounter the rest, log out first so that you can proceed from the beginning, because it's straight away log you in. You're already in, so it won't ask anything. Yeah. Okay. So yeah, let's continue. Right. So talking about virtual LAN configuration. Yeah. So how do we configure? That means we need to access either using console cable or console port on your switch connected to maybe a laptop or PC, or you can use the management via the network cable. right? That means you connect, still remember, you can connect to the switch using terminal emulation software like PuTTY, yeah? PuTTY you on, and then you connect, provide your, it will be challenged by password. Usually you secure it, right? In our ICN last time, we secure our switches, right? So no matter which way you connect to your switch, you need to do that so that you can access the iOS command line interface, right? So that you can perform the configuration. In this case, we want to configure virtual LAN, right? So you can see the objective there to configure a switch port to be assigned to a virtual LAN based on requirements, right? That means your requirements later we'll see, yeah. And then we look at virtual LAN trunks, right? So imagine this, imagine you have a multi-switch local area network. Now you have created more than one, maybe multiple virtual LANs. Each virtual LAN will have its own, well, it acts like its own local area, but it's done logically, right? Physically, they are all connected, but logically, you have now created multiple virtual LANs. Of course, each virtual LANs will be its own network, so it will not be able to talk to each other yet. Okay, later we'll need to see how to configure that. But it will mean that you will need to allow which of the hosts belonging to a virtual LAN can talk to another host belonging to the same virtual LAN. Okay, hosts that are assigned to a specific virtual LAN will not be able to talk to another host that is assigned to a different virtual LAN, right? But physically, all the connection between the switch are just physically one cable, right? So how do we allow, okay, different traffic from different virtual LAN to traverse through the same physical cable, right? So this is where we're going to configure something called a trunk port, okay, to allow virtual LAN trunks. Okay, trunks simply means the pathway where different frames from different virtual LANs can traverse through at the same time, and the switches will know what to do with each frame. Okay, right? So configure a trunk port on the LAN switch, right? And then after that, we're going to look at dynamic trunking protocol. So this is a protocol that will be automatic. So how do you want it to be automatic? In what sense of automatic, right? So we're going to look at that much later on. Right. So let's have a look back and have a look at an overview of virtual LANs, right? So we start with virtual LANs definitions, right? So you can see on the screen. Let me just activate my pointer. So okay, right. You can see on the screens. Here is a building, right? And basically there is just one interface, right? You can see that one interface from the router. So that means, what does it tell us? It tells us that the whole network here is one single local area network. But still, we want to segment it, okay, in a sense that because we want to have different flow having different switches. So we have a main switch here connected to a switch for each floor. Now, remember, even though we have many switches here, since this all comes from the same interface on the router, okay, they are all still the same local area network. Okay, so every host can talk to any host within that same network. And I want you to recall about the chapter 1 about the collision domain and the broadcast domain. Now, collision domain, because since we are using switch and probably we're using switch that is full duplex, means collision domain is restricted to each path only, right? But here we want to talk about broadcast domain. Since this is one local area network, okay, then any host then sending a broadcast frame the broadcast frame will be propagated by all the switches, so it will reach all the hosts within the same local area network. And we already determined that broadcast is actually something that is going to take up bandwidth. Okay. At the same time, it may not be only one PC or one host that's sending a broadcast frame. There might be multiple. Okay. Example, ARP. ARP works based on broadcast. So in that sense, we want to reduce broadcast domain. How do we do that? Well, simply by segmenting the single LAN into multiple LANs. But physically, in order to segment one single LAN into multiple LANs, you need something to separate them, which is the router. Yes, the router. Physically, the router. But we know buying a router probably is expensive, right? So if you add another router or you just have one router, one very powerful router, and then router usually only don't have many ports. So probably one or two ports or three ports, something like that. You can buy modules to add additional port, but it's kind of difficult with the wiring. Okay, let's say we have this one wiring. Add another router. Where are you gonna put? Here, another one here, or here, and then all the wires need to go to that particular router. So it's kind of uh, there's a lot of planning that you need to do. Maybe incur some additional budget. Okay, but if you already have this kind of configuration, what can you do? Well, if you're fortunate enough to have port switches that is Cisco switches, which basically have a VLAN feature, you can consider using virtual LANs, right? So why is it called virtual LANs? Because it's virtual means it physically doesn't exist. It only exists logically in terms of software, right? In terms of software, that means you can say, oh, now I want to configure maybe two virtual LANs, virtual LAN A, virtual LAN B, right? And excuse me, just I'm gonna just close my webcam for a moment. All right. Okay, I have some people. If you can hear some noises, I have some people doing some work around me. Okay, please excuse that. All right, so yeah, let's say I have virtual LAN A and B. Okay, then I can say something like, there's an example here already, so I'm just scratch my example, use this, right? So we have this virtual LAN 2, 3, and 4. So three virtual LANs. Logically, this is my thinking. I said this, and this host I want to assign to virtual LAN 2, which is actually part of IT. Now, IT, HR, and sales is actually departments within organization. And usually in an organization, we segment our business departments very easy like this, right? Very usual, very standard like this. We have IT department, HR department, and sales department, right? So it's then of course logically. Remember, when we say why do we want to segment networks? Sometimes because of this organizational, uh, division, right? Segment. So VLAN 2, we say maybe we provide for IT hosts. IT. That means employees that is using the host and they are IT department, right? And then we have HR and then we have sales, right? And since when we say we segment by virtual LANs, means each virtual LAN is its own LAN already, right? So that means from the network administrator point of view, you have to design network address. So you can see here for virtual LAN 2, we have this network address, okay? Not the two there, compared to this, which is 3 and this 4. So the third octet is used to differentiate between this 3/24 class C networks, right? So now you can see each virtual LAN has their own network. Now, the thing is, the beauty of this is that the physical arrangement, the physical connection, the physical topologies is still the same, right? It's just that we are now defining it logically in software, okay? And it's only achievable because Cisco and of course other manufacturers maybe have this feature as well. Just because Cisco allowed this feature, it is built into the switch configuration, its switch capability, functionality, right? Okay, so you can see that once we do this, the broadcast domain is now reduced. Why? You can see that. Let's look at the definition for broadcast domain. Broadcast domain will exist only in a local area network, its own local area network, and it cannot propagate beyond its own LAN. Okay, physically, it cannot propagate beyond router, right? And in here, without using router, we save money. Yeah? We have 3 virtual LANs. So broadcast originating from virtual LAN 2 is restricted to be propagated within virtual LAN 2, and so on with virtual LAN 3 and 4, right? So even though you have broadcast message in VLAN 2, VLAN 3 and 4 is not affected. It will not be propagated to these other 2 virtual LAN. So you can see there, broadcast, not only broadcast, also multicast and unicast are isolated in their own individual virtual LAN, right? All right. So we'll end up with smaller broadcast domain, and this is good, right? That means it eliminates some of the latency caused by broadcast traffic.
So
Okay.
having more broadcast domain, but they are smaller is better.
Yes. Yes.
Okay.
Because because the broadcast frames will be limited to its own network only. So that means it cannot jump from VLAN 2 to VLAN 3. That is the definition of broadcast, right? Broadcast only works within its own network, right? Okay, the beauty here is that we don't have to buy the router, because in physical network, router is the one that is not going to forward the broadcast frame. So that's why the broadcast is limited to within its own LAN. But here, the features existing inside the Cisco switch allow us, without using router, to segment into virtual LANs. Okay, so broadcast operating based on that initial definition, we say it cannot go beyond its own LAN. Okay, will also uh, uh, use the same concept here. So the broadcast here in VLAN 2 will not go to VLAN 3 or VLAN 4. So that means it's only restricted to here. So here may have latency because maybe of the broadcast frames, but since it doesn't appear here and here, then these 2 LANs does not suffer that latency. Okay, right. Okay, if you have any questions, just unmute and ask. Okay, right. So we go to the next page, right? So we talk about the benefits, right? So you can see that other example on the screen, right? This basically topology up here, where we have 1 router and 3 switches. These 3 switches connected, and basically this is an extended style configuration of topology. But you can see that we have 3 virtual LANs, virtual LAN 10, virtual LAN 20, virtual LAN 30. The 10, 20, 30 is just naming, yeah, just naming, right? It's not an address or anything like that. It's just naming. So a way for us to differentiate between the 3 virtual LANs. Okay, so you can say virtual LAN 5 or whatever lah, right? But the ones that you need to design is for each virtual LAN, what is the network range that you want to provide. Okay, so although we have already learned about subnetting before, right, and subnetting a subnet before in ICN, here we just operate, to simplify, we just operate with a /24, and we segment network by choosing different. In this case, we choose a different third octet, right? So here, virtual LAN 10 is, sorry, fourth octet, third octet, yeah. We use 172, 17, 10, 21. And then the next one, right? Now the 22, 23, as long as you provided different is okay. So 10, 20, 30 should be okay. Right, so, but here, 10, 20, 30, this one, 20, and this one 30. This one is 20, this is 10. Not sure why this one is 20. This one's supposed to be 20, 30 as well, right? We normally, when we are using packet tracer, to make it easy so that we don't get confused, right? So usually if we say we want to use the third octet to differentiate between network address, so we just name VLAN 10, then we use the third octet as 10, 20 as 20, 30 as 30, but I'm not sure why this one is 20 as well, right? Should be 30, right? In any case, this is just an example, maybe that's why, right? So you can see that PC1 belongs to Virtual LAN 10, and same with this PC4. So PC1 and PC4 logically belong to the same virtual LAN. So means in their virtual LAN 10, PC1 and PC4 can communicate. Since PC2 belongs to a different VLAN, PC3 also, and PC5, this is also different VLAN, then PC1 and PC4 will not be able to talk to them unless you configure something later. We'll learn how to configure so that they can talk to each other. All right. Usually we use something called router on a stick, but that was that we will serve that to a later chapters. Okay. Right. For now, we just want to know how. Okay. So this is good. How are we going to configure? Right. For the packet trace exercise, you're going to learn how to configure the virtual LAN. But in the meantime, let's see benefits. Right. So actually, when you think about it, you can imagine what are the benefits already. So the first thing that you can straight away know is that, yeah, smaller broadcast domains, because you segment the network. Therefore, different networks within that logical design will now restrict the broadcast frame. So you have a smaller broadcast domains. Okay. Improve security. In what way? Well, when you segregate the hosts, okay, into different virtual LANs, okay, they cannot talk to each other. If they belong to a different virtual LAN, then they cannot talk to hosts belonging to a different virtual LAN, right? So in that sense, why we segment, we go back to why organization have different functional, segmentation, like departments, right? So usually different departments should not be able to access data from different departments. Okay, you don't allow because maybe it's sensitive. Like for example, HR have employee details, so some employee details are private, so we don't allow salespeople to access employees' details. Vice versa, like maybe some sales data is not private to employees within the HR. So it's good that you separate them, right? So that's why you put them into two different networks. So improve security. Okay, improve IT efficiency. That means you can group devices with similar requirements, right? So uh, maybe faculty are lecturers and students, they have different requirement in terms of IT needs. Maybe for faculty, they require to have a shared drive, right? Share drive, share folder, or share server, whatever, which students do not actually need to access. Or students will access different printers, different set of printers, okay, maybe color printers, whatever, whereas the faculty, the lecturers, uh, prefer laserjet printers, right? So when you attach these different devices into their own LANs, then you can again uh, segregate these services to the departments that need them, right? And then you can then through the networking hierarchy segmentation, you can also do that, the access. Reduce costs. Well, one switch, actually you don't need more than one switch. One switch also can, but we extend with more switches because we expand the network. We have more hosts, right? We have more hosts, and also we might place the host in a different floor, different side of the building. So rather than have many wires, many Ethernet cables coming from all the hosts to a single switch, normally we have a very high speed cable, Ethernet cable from one switch to one switch, and then shorter cables from host to that particular switch, right? This is better design and save costs in terms of wiring as well, right? So reduce the cost. Okay, better performance, small broadcast domains, reduce traffic, improve bandwidth. Okay, no lags because bandwidth is taken up by other things, right? Other things like broadcast, ARP broadcast lah, or whatever lah, right? Simpler management. Well, as a network administrator, is much easier to work with logical segmentation like this, right? Compared to just a single LAN. Without, if you don't have virtual LAN capability, you just have a single LAN, and imagine the nightmare that you want to provide to uh, to increase the performance, okay, to improve efficiency, to improve security with one single physical LAN. It's very difficult, right? Very complex, very tedious for you as a network administrator. But with this, it's simple. All you need to do is configure the virtual LAN, assign which computer, which host belongs to which virtual LAN, and then assign the port it connects to the switch. And then you have logically, you can draw a logical topology diagram, and you can see that segmented. That is easier for you to plan, design, and of course, if you want to scale, right, scale your network. All right, so there are many different types of VLAN. All right, so here in this slide, we want to have a look at different types of VLANs, yeah? Starting with default virtual LAN. So if you have not configured your switch, there is a default virtual LAN already existing within your switch, right? So VLAN 1 is the default VLAN. It will exist even from the factory. You got your switch, you haven't configured anything, you check inside, you'll see that there's already a default virtual LAN, which is VLAN 1. All right. It is the so VLAN 1 is the default VLAN. It is also the default native VLAN. Okay, we'll talk about what is native VLAN later. And then it is also the default management VLAN. What is a management VLAN? Management virtual LAN. Management virtual LAN means a LAN that allows you to remotely connect to the switches to do management. Okay, remember you open up SSH or just a terminal. Encourage you to use SSH because it's secure with encryption, right? So you use SSH to connect to the switch and do your configuration. Remember that? Okay, so it needs to travel inside management VLAN. Okay, so that's why we have management VLAN. And this default VLAN is built in, and you cannot rename it, or you can also you cannot delete it, right? Right. Okay, so while you can see the note there. Yes, we cannot delete the VLAN 1, right? But we can reconfigure. We can Cisco actually recommends that we assign all these default features to other VLANs, right? You can choose, so you can leave it like that, okay, where Virtual Lan is default, native, and management, or you can reassign. If you say I want native VLAN to be some other VLAN, you can. But by default, they are attached to VLAN 1. Okay. So you can see here, if you're in packet tracer, you just type when you're inside a switch. Okay. You can type this command, show Vlan Brief. It will show you a brief overview of all the VLAN you have. By default, you only have one, right? And all the ports available on that switch, okay, by default belongs to VLAN 1. Okay, so you see the trick now already, because you attach your host to the port on the switch by configuring which port belongs to which VLAN. You're basically saying that the host attached to that port belong to that VLAN. All right. Okay. And since you already designed, okay, this VLAN, what network address they have, right? So when you assign the network address, sorry, the IP address for that host connected to that port belonging to which VLAN, right? You already know what to assign. Okay, so this is the idea. See, you can create VLAN. Let's say now by default VLAN 1, all the ports belong to VLAN 1. If you don't do any virtual LANs, you just rely on VLAN 1, fine. It's you run your network just like any physical LAN. This is what we did in ICN, the previous course, right? But now we want to explore more than one virtual LAN. So we might have virtual LAN 10, 20, 30. All you need to do is to configure the port. Which ports belong to which VLAN? And that means that particular port is connected to which host, and that host will belong to that VLAN. Okay? All right. Okay, so the next VLAN is called the data VLAN. Now, this is the normal VLAN. If we create a VLAN, we say VLAN 10, VLAN 20, VLAN 30. This is the type of VLAN that we are creating, the data VLAN. Right? You can see that it's used to transport user-generated traffic like email, web traffic, whatever lah. Typical traffic inside a LAN. Okay, so if you have not configured your switch, everything is VLAN 1, right? So including the data VLAN, all assigned to VLAN 1, because all interface assigned to VLAN 1. So that means the data VLAN is assigned to VLAN 1. Right? Then we have native VLAN. So native VLAN, we only set for trunk links. We don't set native VLAN to the port attached to a host. Okay, remember? Okay, we attach data VLAN to the port connected to the host. Native VLAN is for trunk links, which means the port where the Ethernet cable connects to another switch port. Okay, so this allows us to create trunk links. So native VLAN is used for trunk links. What is trunk links? Where traffic from different VLANs travel together. They still need to travel between one switch to another switch, right? So where they travel together between switches. So we use trunk line links for that, and we call that native VLAN. Okay, right. So how to differentiate between one frame from one VLAN and one frame from a different VLAN? Well, they are tagged. These frames are tagged, right? And they are tagged on that trunk link, the H02.1Q trunk link. So when you reach the other port, then they know, okay, this frame coming from this trunk link is supposed to go to only these ports because it belongs to this VLAN and only this port belongs to that VLAN example. So how do they know? By looking at the tag. Okay, later we'll see what tag is that, right? So frames that are not tagged, there is no tag on them, that means you can't tell they are from which VLAN, okay, are those that belong to native VLAN. Again, we'll explore more about why for native VLAN, why we don't tag the frame. Okay, and then next one is the management VLAN. Remember, I said that management simply means manage the switch, right? There are two ways, right? One using console port, but you physically need to go near the switch, plug in your console cable to the console port on the switch, and another one to your maybe laptop, right? But most of the time we don't want, because switches are normally kept inside a cupboard, a rack, or whatever, that we don't really want to go in every time. So we prefer to set up SSH right on that switch so that we can remotely, okay, via the management VLAN, remotely access the switch. That's why Cisco switch has an IP address, but it is this IP address on the switch is attached to this management VLAN. Why? Because if we want to connect to the switch, we need an IP address, right? For the application, okay, like SSH or terminal emulator, right? So you can see there, management VLAN, this is used for secure shell slash telnet. Telnet is normal terminal emulator. There's no security. SSH is the secure version with encryption, right? So the traffic, management traffic, okay, goes through management VLAN, okay? And they need to be separate. They should not be related to any other data VLAN, which data VLAN have the end user traffic, so you cannot use management VLAN on data VLAN, right? Typically, the VLAN that is the SVI for layer 2 switch. So this is the VLAN to manage layer 2 switch lah. All right, so that you can connect to your switch. You can open up your iOS and you can type command to manage your switch. All right. The next one is called the voice VLAN. So by the name itself, you know already lah. This virtual LAN carries voice traffic. You know, voice over IP, right? We are allowed to digitize our voice and send off in packets, right? Or in this case, frames lah, because we're working with switch, right? So Cisco prefers you use separate, okay, virtual LAN to carry voice traffic. Because why? Because this is a special traffic, okay? In order to ensure that the voice communication, or voice transport, or voice transmission behave in a stable way, right? Then you have to be able to not consider other traffic to mix in with your voice traffic. right? Okay, so the requirements for a traffic, that's why we need a separate voice VLAN, is assured bandwidth. No other traffic is going to disturb the voice traffic, because any latency caused by broadcast or whatever data traffic will cause drop, okay, in the performance or efficiency for that voice. And then you'll see that the user will see that the laggy voice or echo in voice or breaking up, okay, something like that lah, right? Because it's using UDP, so drop will not be considered. So sometimes you'll see some static lah together with the voice traffic. Then you can then ensure high quality of service priority. All right. Ability to avoid congestion. Congestion is bad for voice traffic, right? And then we can ensure that the transmission is below, if any delay, but it's below 100 milliseconds or microseconds, sorry, from the source to destination. Okay. Now, if you do consider voice traffic, right? Let's say, you have voice VoIP application or products. Okay. Then you need to plan it from the beginning. You can see there the entire network must be designed to support voice. Means you then will have to create a dedicated voice VLAN where VLAN traffic will flow through. How do you do that? Well, you create the voice VLAN, and then the port that's attached to the VoIP hardware or end device will be plugged into that port, and no other devices or host or end devices that connects to the port assigned with voice VLAN, okay, apart from voice over IP capable end devices. Okay. Is that okay so far, everyone?
This one voice only, you mean like call or something like video
Yeah,
call?
yes, for VoIP. There are certain product that is, we can use our computer for voice over IP, but it's a mixture, right? It's a mixture. There are some products like, like a phone, which basically you can't use for anything. It's just for call.
The phone counts as a VLAN, can count as a type of VLAN also.
Not the phone that carries
the line, but
yeah,
another
yeah. This is a network. Yeah, this is a VoIP phone. It will very clearly say in the box or on the maybe on the description of phone. It's a VoIP phone.
Like
No,
about
yeah.
a mic also count.
Okay. Well, if it's attached to an end device that only produce VoIP frames, yes. You see, why we want to have this kind of, just why not use them? Because remember network convergence. Typically, we have a PBX system, we have a phone we buy, and then it runs on separate network. Remember, separate wiring, separate for phone.
Yeah.
Typically, normal business. This one is convergence. You don't have to have any other cabling. You simply have a network cabling all over the place, right? So you say, hey, then how do I use my phone? Remember, how do I use my phone? So now you are saying, okay, we'll purchase VoIP phone. This phone connect directly to the network. For the end user, there is no difference, right? Unless it's lagging. Unless it's lagging. That's why we have voice VLAN.
So must
voice
VLAN,
yeah.
Must be line, can be wireless, or you must use line.
Wireless. The thing about this, if your wireless is the same, you don't allow any other network traffic. That means you disallow any other connection apart from It doesn't matter wireless or wired. All
Oh,
you need to do is make sure the device that connects to the voice VLAN are only voice over IP device.
okay.
They don't produce any other data because it will lead to congestion. Any
Mm.
other data means normal network traffic, and it could be broadcast. It could be. We don't want any of that, right? We just want voice traffic, voice packets, voice frame in this case because we are working with frames, voice frame lah. Okay, no other traffic apart from that. That's why when we are confident, if we only have those, we can then prioritize and we can assure the bandwidth. There's no congestion. We can ensure there's no latency lah, right? Okay, so imagine that instead of having the normal typical phone network inside your building, phone cabling and all these things, PIBX system, all this, you just use your network cable. You dedicate one of the VLAN to voice VLAN, okay, and then when you plug in the cable, or is it wireless, go to wireless AP, whatever connection mode, but the device is a voice over IP device connected to that particular port, connected to that particular voice VLAN, right? So it's actually save a lot of costs. Yeah. Imagine not having to do double wiring. Yeah. Okay. So, but that means, but you have to really plan lah. Really plan that your network logically lah. Physically is well, you can you provide how many ports, then you think about it lah. In this part of the building, how many PCs, how many VoIP, how many network printers. You have to design it lah, right? And then after all the physical wiring configuration is done, then you say, okay, so I must have this VLAN, and because I want to use the network LAN to carry voice over IP traffic, then I need to create one voice VLAN, and this voice VLAN will only on the switch only connect the port that is assigned as voice VLAN, only connect to VoIP device, right? Is that okay, Kelvin?
Okay.
Right. How about Noel and Farah?
Okay.
Okay.
Okay. All right. So we'll move on. So if you think about this, this is quite cool. It save a lot of money for for the company actually. Not to say that the switch is cheap lah. Okay, it's also not cheap the Cisco switch, but considering that buying routers, routers even more expensive, right? All right. So packet tracer exercises related to this is the one that's titled "Who Hears the Broadcast." Okay, in this particular packet tracer activity, you can get it from probably I'm not sure, I haven't checked the practical yet, but definitely you'll find this in your NetAcad online. Okay, this packet tracing activity, you can play around with it to, help you understand broadcast traffic. All right. All right. So the next section, we're going to look at the virtual LANs in a multi-switch environment. Okay, just now we're just getting to know virtual LANs. So now we see them in operation. How is it? Right. So here we are given an example LAN. You can see that we have three switches, VLAN 10, 20, 30, LAN 20, 30. So PCs that belongs to the same VLAN can talk to each other. So that means VLAN 30, VLAN 30. Okay, these two can talk to each other. Student VLAN 20, student VLAN 20. These two can talk to each other. This one, faculty, these two can talk to each other. This cannot talk to this, cannot talk to this. They basically cannot talk, VLAN 10 cannot talk to 20 and 30 and so on, right? Because they are different network already. Okay, you can see that network address there. Okay, they belong to different network. Okay, so we already talked about that. Now, from the switch to the host, we know that we can configure that as a data VLAN port. And how we configure that port, okay, if we say it's, oh, this port is VLAN 30, then this computer here, by virtue being connected to that port, is part of VLAN 30. Understand? Huh? Now, VLAN trunks, you cannot create between switch and host, because VLAN trunks, the functionality is to carry different VLAN frames. Because you see, if this gas can talk to this gas, but still need to travel physically from here to switch 2 to switch 1, and then switch 3 and to this PC6, right? So what about, we know this is this port is set as VLAN 30. This port is set as VLAN 30. So this too belongs to VLAN 30. But what about this and this? VLAN 30, well, if I set VLAN 30, this is VLAN 20. So VLAN 20 cannot pass, right? So instead, we call this, or we assign this as Vlan Trunks. Vlan Trunks allow more than one VLAN traffic of frames to pass through it. Okay? Right? Okay, so by default,
Okay.
VLAN trunks allow to carry different types of VLANs traffic. VLAN 10, 20, 30, no problem, can pass through here. But this is VLAN 10, VLAN 10 port. So VLAN 30 cannot enter here. It's blocked by the switch here already.
Is there any like limit? The VLAN?
Yeah.
The trunk is any limit?
The trunk here, no limit. No limit. And the VLAN, I think the limitation is how many the switch provide to you.
Oh, which one is the trunk?
This one, between switches are trunk lines,
Oh,
or
the
trunk
trunk
link.
Oh,
Because it needs to carry this traffic, right? But they are different VLAN. So
it's just
or
a line.
VLAN,
Oh, it's just a line.
It's a line. Yes, you have to configure VLAN trunk in order to let the switch forward a different VLAN traffic through it. Okay, that's the only reason why we use VLAN trunks lah. So different traffic can travel through this different VLAN traffic lah, frames, right? Okay, so well, you can see 802.1q is a protocol. So it's a standard protocol. So there is a standard protocol that achieves this. So Cisco supports 802.1q protocol for trunking. Okay, right. So trunking is just a keyword to say that, okay, trunk will allow different VLAN frames to pass through the trunk, through this line, through this cable. Okay.
Okay.
Right. So network without VLAN. So this is just to highlight the point to you guys about the importance of having this feature for Cisco, right? So if you buy switches that do not have capabilities like this, like VLAN capabilities, they all, this is not VLAN, it's normal, this plug and play, or by default you didn't. If you buy switch,
is the VLAN trunk a different type of line, or is just some? You just need.
No, physically it's the same.
So
all of these are logical.
Oh, so
all this configuration.
You just configure it only.
Yes.
To become a trunk. Okay.
Yes. Physically, there's no difference. It's normal. You could have this. Maybe you purchase Cisco switch, but you didn't do any configuration. So it's just a normal, typical, like in ICN we learn, normal typical LAN, right? This one can talk to this PC can talk to that, you know. The broadcast also can, if this one broadcast, it goes all over the place, right? But with know-how, and if this is Cisco switches, you know, oh, I can do VLAN. Then you can configure the ports to be VLAN ports and then trunk ports here. Suddenly, if VLAN 30 broadcasts, it doesn't go here, 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 here. It goes only to here because only to the same network. You see? Right? And physically, there's no difference in the cable. You don't have to buy new things, whatever. You can just configure logically. That means through software, through configuration of the switch, right? So this one tells us in a normal LAN, without VLAN, one broadcast will go all over the place. In a VLAN, depending where the broadcast was initiated, it only goes to another host belonging to the same VLAN. So let's say this PC1 generates a broadcast frame. It will only go to this PC4 because PC4 belongs in the same network, same VLAN, right? Okay. Right. So it says with VLAN, not only broadcast traffic, but multicast, unicast, whatever traffic is confined to its own virtual LAN. Right. So what does it mean? Do you see any router here? Anybody?
No.
No router, right? And to connect networks together, we need a router. So if we only have switches, okay, switches are not the multi-layer switch, just a switch, then your VLANs cannot talk to each other because there's no router. There's no layer 3 device. So although good, we have segmentation, but we're missing that. That means we're missing something like, okay, let's say from VLAN 10, I want to send a message to VLAN 20. You can't. There is no layer 3 device. That's a problem. Okay? So you must at least, if you don't have multi-layer switch, you must have at least one router. Okay? But then again, we will talk about that, right, under heading router on a stick later. Okay? How we learn about configuring VLAN first and talk about all things about VLANs. Later, we learn about how to, what about if I want to send a message or frame from one VLAN to another VLAN? We'll talk about that later using a router. How to configure the router to support VLANs. Okay? Right. So first, the trunking here. How does when we send frames over here, over this trunk, we say that we can send frames belonging to different VLANs through this same physical line. But how does the switch know the frames flowing through it belongs to VLAN 10 or VLAN 20? Because let's say VLAN 10 wants to send to VLAN 10, or VLAN 10 here broadcast should reach here, right? Right. So it sends to here, and from here there is no other place to go but this trunk line. So propagate here again, trunk line propagate here. From here, it looks at still look at the table, right? MAC table. But how does it know that this can go to this VLAN 10? Well, because of tag, right? If you implement IEEE 802.1q protocol, right, there is a tag, right, that is created to identify the frame belong to which VLAN. Now, when you use the tag, right, you add on the tag, right? So FCS that was created must be recalculated to include the content of the tag, or else it will be considered as, hey, how come it's changed already, right? So when it's sent to the end device, this tag again remove and recalculate the FCS back to original number. Just this is because remember FCS is used at the trailer of the frame to check whether the frame is corrupted or not. So if you add something to it, of course the FCS will be different. So to avoid that frame being discarded because the switch thought that, oh, okay, this is not the same FCS CRC value, then you have to drop it. Okay, so that means once you add a tag, you recalculate FCS, store the new value. If you remove the tag, then you have to recalculate FCS again to store the new value again, right? So the tag field, right, has a 2 byte with the hexadecimal of this. We call it a TPID, or tag protocol ID. And then there's a type, a 2 byte field. And then 3-bit value that used to indicate user priority. And the CFI, or canonical format identifier, is a 1-bit value, which allows you to use it in a token ring as a token ring frames. Okay, so basically in a normal Ethernet switch, we don't set the bit lah. Okay, if you using it with the token ring, Ethernet token ring topology, then right, you can use this bit value lah. You set this bit value. Then after that, we have the 12-bit VID, and this is the part of the tag that allows us to identify which VLAN this frame belongs to. So maximum is 4096. This answer, Farah's answer just now, but not all switch support all the way to 4000. I'm not sure the Cisco switch, which model, right? Which model support up to, we have to check later lah. Packet tracer, we can check depending on the switch you select in packet tracer, how many VLANs can you go, the switch support lah, right? But this protocol support up to 4096 VLANs. Is that okay, Farah? Does that answer your question earlier on? All right, so I'm not sure Farah is.
Sorry, I was out just now. I closed the window.
Okay.
Rain, yeah.
Okay, no worries. I was just answering your question earlier. Say, is there any limit, right? The limitation for the switch is based on the model. When you practice the packet tracer, you can check how many VLANs you can create. But if you're based on the IEEE 802.1Q, then the maximum is 4096 because it supports 4096 virtual LAN. I think it's more than sufficient, right? If you I think want more than that kind of VLAN, that means you're better off to physically create first, and then you can then expand, right? Okay. All right. So let's go to the next one. This is VLAN identification with a tag, used to identify when it's traveled through trunk lines, right? And later on also when you're using router on stick. All right, so let's have a look at native VLANs. Remember what is native VLAN? Native VLAN by default is attached to VLAN 1. Remember, and native VLAN is the only VLAN that is allowed to not to have a tag. So if you can see here, the point being made as native VLAN and 802.1Q tagging. Okay, so let's look at 802.1 tagging. Okay, right. So if you employ this protocol, This tagging is done on all VLANs, right? So we have native VLAN is meant for legacy use. That means if your network has a mixture of new devices and legacy devices. What are legacy devices? Example, hub. Okay, hub take the job of a switch, but actually before the switch was created, we use hub. But hub is a poor device in the sense that it is only up to layer 1. That means it does not recognize MAC address, therefore it's basically broadcasting all the time. Okay, remember, switch identify frames going to which port in the hub works on layer 1. There is no MAC address, therefore for hub it just replicates the signal basically. Okay, replicate the signal to all the ports, all the egress port rather than excluding the ingress port lah. Right, so for hub there is no frame. So there is no frame means there is no tagging. Recall that we tag, where do we tag? In the frame, right? See, destination MAC, so then tag. Since hub does not work on layer 2, that means it does not have access to frame, so there's no scenario. So by default, VLAN 1 is pre-existing in your switch and is assigned with native VLAN. Basically all VLANs assigned to VLAN 1 right, including native VLAN. Okay, so if you think your network have legacy networking device, right, then you need to configure native VLAN. Okay, where there is a trunk line. Okay, when you configure trunk line, don't forget to also configure, right, the native VLAN. So if VLAN 1 is native VLAN, then configure configure it for the trunk line also. So you can see that both ends of a trunk line or trunk link must be configured with the same native VLAN. Right? So each trunk is configured separately, so it's possible to have a different native VLANs on separate trunk. Yeah. So basically, what it means that we have, because we don't say that it's trunk here, because it's not a switch. So the trunk is basically all the way from this switch to this switch. Since there is a hub, right? So we need to enable native VLAN here, so that legacy can work also. All right. You'll see the explanation here. When an untagged frame arrives on a trunk port that is assigned with native VLAN, management frames that are assigned between switches is an example of traffic that is typically untagged, because management VLAN is not belong to any VLAN, at least data VLAN. It belongs to management VLAN and it's untagged. Why? Right? Because you might want to be able to connect to your switch from any of the VLAN, right? You don't restrict yourself as a management VLAN to any particular data VLAN. Okay? If the link between the two switches is a trunk, the switch sends the untagged traffic using the native VLAN. Okay? So because if we set this as trunk link, right? So We say frame, checking frame, tag, frame tag, right? Oh, okay, this one don't have any tag, so I'll send it via the VLAN, native VLAN. So if you don't configure native VLAN, what happened? Then untagged frames cannot pass through. Okay, okay, so there are other, these are also as, yes, sorry, is that Noel?
No, nothing. Okay.
What is the CDP, VTP,
All right.
STP?
Okay, I already, off the top of my head, I only recognize STP traffic lah. Later we can check lah. CDP and VTP. Sure, in the next slides or inside our next STP lah, I recognize straight away. Okay, this is the one that based on the STP, the spanning tree protocol. Spanning tree protocol is used to avoid circular transfer of frames. Remember I said that you can configure a switch like this. I can put a switch here. I can put a switch here. Then I can connect switch here. Connect switch here. Connect switch here. Like that. Right? Okay, so here is computer. Why we want to connect like this? If this one,
Is there a pointer?
sorry, I got disconnected just now. Can you guys still see my screen?
Oh, okay. Oh, can see.
Is it okay now? Can you hear me now?
I think so. Can?
Everyone? Yeah, okay.
Yeah.
Can I?
Yeah.
Right, so you can see on the screen. Okay, so like this one is a switch. So also a switch. So you can see, you can imagine this kind of configuration where you say, oh, my network is critical. I cannot have like any disconnection. So let's say this one disconnected, then the switch can still pass the frame to this switch, and still can reach this PC. Right? But there can be a situation where the traffic can go like this, merry-go-round. Okay, and it goes round and round and round and round. We don't want that. Okay, so spanning tree algorithm implemented as a spanning tree protocol. Later we'll also in this course we're going to do that. Okay, we're going to learn about STP, STA. Will allow us to have this kind of configuration of switch, but still prevent the circular flow of the frames inside the network. All right. Right. So STP traffic works on all frames. It's not only, we don't just want to say, oh, VLAN 1, I protect from this kind of problem. We want to protect all VLANs traffic from this kind of problem. So we cannot tag it to a particular VLAN. So that's why STP traffic needs to be untagged, because it will operate on all traffic. Okay, so this is an example of untagged frame. Why we have an untagged frame for STP. Okay, we'll find out what is a CDP VTP later. Okay. All right. So next, we'll look at voice VLAN tagging. Remember we talked about voice VLAN, right? So just to carry voice frames to ensure quality of service so that we don't have lag when we're using VoIP device, right? We're talking to whoever lah, right, on the network. Okay, and the configuration, you can have the voice VoIP frames when it reach router and it goes, it will be forwarded to the network in general, to the internet. Okay, and once it leave your router, you have to basically deal with your service provider lah, the ISP. Say, oh, I want to have voice. It means you have to purchase different types of service compared to home users lah. That's why business use cases, and they have different products lah, more expensive products for businesses because they have this kind of use case lah. Like for example, carrying voice traffic outside of your network going into ISP network. Okay, but in our LAN, right, we also want to ensure our voice traffic will have no latency, no lag, right? We want to make sure it's work within a certain critical space to be transferred lah. It means period of time. So VoIP phone is a 3-port switch. The switch will use one of the acronym just now, we're not sure, CDP, right, to inform the phone of the voice VLAN. That means the port you connected, okay, is this a voice VLAN? So basically the phone, the VoIP phone will be able to know using the CDP, right? Right, so the phone's VoIP phone will tag its own traffic, which is voice traffic, okay, and attach with it COS, or cost of service. Okay, cost of service is similar to QoS, or quality of service, right? But quality of service works on layer 3. Since inside LAN we only reach up to layer 2, we must be able to have the same functionality as QoS. QoS go all the way onto the internet already. The ISP will handle QoS, right? But for switch working on layer 2, then it will work with this COS, cost of service, right? Right, so may or may not take frames from the PC is up to the phone, right? So we have voice VLAN tagged with appropriate layer 2 class of service priority value. Okay, and access VLAN is the port here. Okay, can also be tagged with layer 2 cost priority value, or you can also set that it's not tagged, this part, the access VLAN port. Okay, up to you lah. But the phone will tag lah, right? Depending on whether the phone operates with the COS or not. Depending on the phone lah, the phone model. Right. Here is a command you can type in the switch. Okay, example of checking or to verify voice virtual LAN. Okay, so basically FA or fast Ethernet port 18. Okay, switch port command can show both data and voice VLAN attached to that interface or that port. So just simply type show interfaces FA 18 switch port. Okay, which means the switch port lah, the port on the switch. Okay, you can see it's enabled. First of all, it's enabled, so it's up. Right, static access, operational static access, trunking encapsulation by negotiate. We'll talk about that. Negotiate means it will depend on the other end of the cable. And then operational trunking encapsulation is native. Negation of trunking off, access mode VLAN. So this is access mode port for VLAN 20. Okay, and you allow voice VLAN to come in from that port also. Okay. So you can see native VLAN tagging is enabled. Right. So then this one, if you see this, means this port is enabled with voice VLAN. Okay, the 150 there is just a label, just like this Vlan 20. Okay, you can use any label, but it typically, as a network administrator, when we design the network address, let's say like it's now the third octet, I use 20, so I just put 20 there, right? So easy for us to relate the name of the VLAN to the network address, okay, that we have already specified for that VLAN. Right, so the packet tracer related to this section, this topic, right, is to observe broadcast traffic within a VLAN implementation and without VLAN implementation. So you expect to see the traffic restricted to the particular VLAN the broadcast traffic originates in, and restricted to those PC that has VLAN, those VLAN port. Okay, and you, for part one, you expect to see the without VLAN, you will expect to see the broadcast traffic go to all the hosts. Okay, this is what you should expect, and if you do it, okay, you should be able to see that. Okay, the best way to see is use the simulation mode, right? So in this packet tracer, you probably need to use simulation mode so you can see that the frame slowdown show you where it goes. Okay, right. So the next part, the next section is all about VLAN configuration. So here is how you configure. 3.3 is how you configure your packet tracer exercises, how you configure your switch for VLAN. Right. Now, again, this one is answering Farah's question earlier on. Okay, what are the VLAN ranges on the Cisco switches? The model, the catalyst model. Okay, you can see that VLAN ranges on catalyst switches, right? So, this model support more than 4,000, support over 4,000 VLANs. So, perfectly matched with the IEEE. Just now we talk about the protocol, from the frame ID, able to support 4096. Remember? Okay, so this model supports all supports the whole range, right? Okay, so when you operate, of course, you can go all the way up to 40 something, yeah. But typically we only use this range, okay, from 1 to 1005. So typically we use it in a small to medium-sized businesses, right? I don't imagine that you will only use VLAN or use Cisco switches for home use, unless it's small office, home office, or SOHO. Probably if you have your own home office and you have multiple people using it, maybe you will try to buy it, but it's meant to be used by businesses, okay, small to medium size. Right, so the range 1002 to 1005 is reserved for legacy VLANs, and 1002 to 105 are auto-created. Remember the default one, and this cannot be deleted. Okay, so all the configuration for the VLANs you created and so on, okay, you create VLANs and so on, will be stored inside the vlan.dat file. Okay, stored in the flash drive of your switch. So typically, if me last time, if I'm learning and I mess up all my VLANs. I want to restart over. I simply go and delete this file, restart my router, and not my switch. Okay. All right. If you ever find yourself, if you're on packet tracer, it's easier lah, kan? But if you're working with the real switch, right, and you mess up all the configuration of your VLAN, you want to start over, simply delete that VLAN.dat is okay, because this by default cannot be deleted. No matter how you try, you cannot delete. This one. VTP can synchronize between switches. Not sure what's this acronym for. Later we'll check. Yeah. Now the range between 106 to 4095 to the maximum is typically used by service providers, means your ISP, and they are stored inside running config. Right. Okay. So different. So this range inside VLAN.dat. This range inside running config. Running config. Remember, if you want to keep it for the next, after you reset your switch, you have to do self configuration, running config, save this configuration. Then you will carry over to your next session, right? And this range supports fewer VLAN features and require BTP configuration, whereas this one I think is dynamic. Right, so how to create VLAN? What are the commands? Right, first of all, after you successfully go into your switch, you have to go configure terminal first, or config T, right? And simply type the command VLAN and the ID. So it can be anything, 10, 25, whatever. But remember what I mentioned earlier on, we will put the ID similar to the one of the octet that changes for the network address, so that easy for us, the network administrator, to identify. So, VLAN 10. I know the network address list with the one that changes is a 10. So this one belongs to the 10 network address. The other one maybe 20. Okay, so VLAN 20. Okay, it's just a convention. It's not a hard and fast rule. It's just for you to make it easy for you to identify the VLAN and its network address. Right? You can provide the name. This one is description, alphabetical. Okay, this one so that you can say, because ID is still not very easy for us to, doesn't provide meaning to us. Okay, so we provide name, so it give meaning like student LAN, HR or human resource LAN, okay, student, faculty, whatever, a description, meaningful description, right? And then after you finish, you've created that VLAN, type N to exit config VLAN, and then I don't think you need to go to configuration mode again, right? And that's it lah. If you want to configure multiple VLANs, before you type N, continue to create VLAN. Okay, VLAN 10 name, VLAN 20 name, and then so on. Right? I don't think we need to do this after, if we finish already lah. Just type N, and you're back to privilege mode of your switch. Okay, so this is a way that you're going to type on just now. Let's say you have a student PC, right? You want it to belong to VLAN 20. So VLAN 20, we'll have this kind of address later, right? Because this one you have to design as a network administrator. You have to design the address for each VLAN. What is the network address? What from the network address, the range, you find which usable host IP address within that network range to assign to your end devices. So when you type this again, computer terminal, we want to call it ID 20, so VLAN 20. We want to giving meaningful name student, and finish by typing N, right? Right, so once the VLAN is created, then you see, this is the student PC. Student PC belong to VLAN 20. You went to switch 1, you configure VLAN 20 and name it student network, right? So the port on the switch that's connected to that particular student PC is port 18. Right? Then type switch port mode access. The mode access is typically given to a port that is connected to end device. This will never be mode access. Okay? Not mode access. This one, mode access, because it's connected to end device. Right? So switch port mode access, switch port access the VLAN. What VLAN? Since just now we say, oh, we want to allocate VLAN 20 to this PC, so we'll configure this one as VLAN 20. Okay, so replace the VLAN ID here with 20. Then that's it. You end. Okay. Right. So here is the full command. Configure terminal interface FA 18, fast Ethernet port 18, switch port mode access, switch port access for what? VLAN 20. N. Right? So what address you want to put on student PC is up to you. Okay. Let's say you already decided, oh, VLAN 20 is a slash, I think 172. Okay, it's slash 24. Is it slash 24 or is it slash 16? Anyway, 172, let's say it's slash 24. So 172.17.20.0 is the network address. So maybe you say, oh, so .22 is this PC2 lah. And you put there. Right? So far, okay?
Okay.
Kelvin, Noel, Farah?
Okay.
Yeah.
Following, yeah?
Okay.
Yeah? All right. So we go to the next data and voice VLAN. So data is the typical or normal VLAN. This one you can consider as data because it carries normal traffic. Okay, it's differentiated with voice VLANs. Right. So an access port can only have one data VLAN. Of course, one end device connect to the port. Network traffic should be only one data VLAN, VLAN 20, for example. However, you can specify a voice VLAN. Okay, if you also have a VoIP that connect to the same switch port. Okay, it's just that the traffic from the PC5 goes to the or via the data VLAN, and the voice data from the VoIP device will go through the voice VLAN. Okay, so you can have both the data VLAN and voice VLAN configured for the same port. So you might have voice over IP as a physical product or as a software inside PC5, but you have to configure maybe that software VoIP, then it will automatically use the voice VLAN rather than the data VLAN. All right. But typically in a business, they use a dedicated device lah. Okay, they buy the. It looks like it's exactly like any other phone, but it's actually a voice over IP phone. Right. So here is example for you to set the voice VLAN and the data VLAN. If you say that the FA0 /18, the port 18, can have both data and voice. So this is the way you configure, right? Okay, so first of all, you configure you want to create the VLAN 20 for data VLAN, provide the name student, okay? And then you create for VLAN voice, we give it a VLAN ID 150, VLAN 150, we call it voice, and then exit, then we go to the interface and type switch port mode access, okay? Switch port access VLAN 20, this one is for data, we learned earlier on, and these ones are for the VLAN 150. So you have to type this MLS QoS trust COS, right? This indicates the kind of services you want for this voice VLAN. Then type switch port voice, not access anymore, switch port voice VLAN 150, and then you end. Okay. Right, so the next command is to verify the VLAN information. Okay, so the command is show VLAN. Now you can append, this is optional, you can append brief if you just want a quick look, right? Quick look on, and you can also reduce filter to a particular VLAN by specifying the ID or the name, right? Okay. Summary means there's more information, right? Brief, it just gives you the name, status, and ports assigned to that VLAN. Okay. Right. So this is an example of us showing that. Show VLAN summary. Then number of existing VLAN 7, existing VTP VLAN 7, extended VLAN 0. Right. And then show interface VLAN 20. Basically, we just want to see the VLAN 20. So it's a protocol up. Nothing much here, right? Just this one basically just tell you the port, okay? The hardware port, the value, right? And changing the VLAN port membership, okay? So let's say you change your mind, you already assign a port to a particular VLAN. So how do you replace it? That means maybe it used to belong to this VLAN, so I say I want to change, I make a mistake, right? Okay, you have to re-enter the command, but before that, use the keyword no, right? This is always indicate to iOS, okay? It also work with other commands. You put no in front, you will basically delete that entry, okay? iOS will interpret that as, okay, remove that entry. So type no switch port access VLAN, right? Then the interface will be released from that VLAN you access, okay, before to the default VLAN. Okay, if you remove the entry, let's say the switch port access is dedicated to VLAN 10. If you type no switch port access VLAN, right, the interface will be switched back to the default, which is VLAN 1. Okay, this one default. Okay, then after that you just recreate switch port access VLAN, the new ID name lah. Let's say before it's 10, remove it, it belong to VLAN 1 again. Then you create VLAN maybe 20, right? And then try and then see whether the new VLAN is available. So 10 is lost, 20 is there. Okay. Sometimes we make a mistake. Huh? We want to just change. So basically remove it and then create the correct one. Hmm? Yeah. This is to verify lah, show interface switch port. So now it's default, right? And then you have to redo your command to assign that switch port to the correct VLAN, right? Deleting VLAN again. Simply put no VLAN, and so say VLAN 10, no VLAN 10, right? But before you delete the VLAN, do the earlier part that we do, which reassign all member ports to different VLAN. Okay, VLAN 1 is the default one lah. Okay, so remember I said that we can delete VLAN.tat very quickly instead of deleting one by one. Just delete all the VLANs by deleting this is a command. You can do flash colon or just simply delete VLAN.dat. Right? Then to that reload the switch. Type reload. Okay. Now this is important actually for the real hardware switch. Unplug all data cables, erase the startup config, delete the VLAN DAT, reload the device. This is the one of the reasons is because in a lab, Cisco lab, some students they don't clean up. Okay, when they configure, they save everything, and then when they switch off, okay, the next group of students comes in. The switch still got all the configuration from prior to that lab. Okay, so if it might be annoying to students lah, right? This is the fastest way for you to ensure your switch is ready for you. Okay, unplug all data cables, erase that startup config, delete the VLAN file, reload your device, and you'll find that the switch is returned back to factory mode. That means all the configuration is back to default. Okay. Right. So I'll check within the 7 weeks if our lab is accessible. Maybe I'll ask them to just prepare maybe 3 sets. Okay. If you guys want, we can just drop down one afternoon and then try it out lah. Try out the hardware. Okay. But I can tell you it's the same lah. Whether you use packet tracer or hardware. Hardware is more difficult. My experience is that with hardware, you have to deal with a lot of other things like cable is damaged cable, unreported. Okay, again, some students maybe very rough. Some network cables damaged, they didn't report it. So it's just stored together with the working cables, network cables. And when you try out, how come my connection not working? Then you have to test the cable. All this delay your work lah, right? Whereas packet tracer is perfect, isn't it? Packet tracer is perfect. There is no way that you can you just reset packet tracer, right? Because it's simulator. All right, so Packet tracer, if you want to try it out online, I'm gonna wait until the practical later. Is you must know how to verify the default VLAN config, right? Configure the VLANs and assign VLAN support. All right. So in this, this is I remind also for benefit of Farah. Okay, Farah, this course this semester we have two assessment tests, which is on week 4, that's written test, and um, the practical test called skill-based assessment on week 7. Right? That means you'll be using packet tracer. Lah. There is no assignment for this course, test and practical test. Okay?
Okay.
So make use of the uh, the chapter exam, also the materials online on NetAcad for your revision. Okay, if anything you're not too sure about, let me know. We have, although we have only 7 weeks, the content is still remain the same. So double the content per week. Okay, two lectures, 2 tutorials, 2 practical per week. Right. The only good thing is that you have reduced courses. Okay, but the content remain the same for the course that you are on. So you have to be a little bit more rajin lah, to do revision. Okay, okay. So that's it for this lecture. We'll continue with Vlan Trunks and the rest of the content in the next week's lecture. Okay. All right. So it's 3:30. Right. So let's disconnect and connect to the tutorial. Okay. In the meantime, let's have a quick 5 to 10 minutes break before we do our tutorial. But let's leave this meet and join the other meet lah. Okay. So guys, I see you in the tutorial meet.
Okay.
Hello guys, 5 to 10 minutes break. Okay.
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 Hi, welcome back. I've shared the second tutorial, assigned you guys also. All right, so the last one, I think number 10, you work together. Question number 10, you work together to identify. Okay, because there's a problem with the network, right? Document the problem discovered, potential solution using template in table 22. So straight away, just enter your answer in the table 22, right? We work together on the question 10.
Okay.
Yeah, I know that if all of you already managed to access the NetAcad,
Yeah.
Okay.
Mine got.
sorry, Farah, yeah, what did you say? You managed
Already got.
already?
Yes.
Already. Okay, Noel,
Haven't tried yet.
haven't tried. Kelvin already can access already, yeah, Kelvin.
Yeah.
Okay, so Noel, you access lah, so you can access the materials there.
Okay.
Farah, you also can attempt the tutorial 1 first if you haven't finished your tutorial 1.
Okay. Yeah. I did try attempt last night, but too tired already.
Yeah, I understand. It's okay.
So is this considered successful?
Yes, can you click on it? Can you access launch course? Try launch course.
Just
If you're able to access the
also.
materials, yeah, launch course. Yeah, so go down. Yes, access the modules. Let's say modules 1 to 4.
This one.
Switching. So can yes, you can access already. Okay, correct lah. Can access. Guys, if you're having problem with number 7, number 8, number 9, number 10, just leave it for a while, lah. Okay?
Oh, we haven't reached that
You
part,
can
right?
try, but yeah, leave it for a while because
9 quite hard.
you notice 7, 8, 9, and above, they're all part of the second part of our lecture.
Oh,
Okay?
okay.
So if you find difficulties understanding the question, just leave it first lah, right?
Okay.
You can try lah, but I think maybe better you wait for the lecture next week lah, for that part. All right. All right. So from the question, let's discuss. Okay. So most of you got all it correct. Just missing some details. Okay. So for tutorial 2.1, what is virtual local area network or VLAN? I just add there in red color. Okay. Some more details about the answer. And basically for part I, data VLAN as well as native VLAN, also the same, yeah. Just add in more detailed answer. Okay, for management VLAN, the second part, Farah's answer is correct, but the first part, allowing switch to connect to internet or cloud, it's basically because switch without a router, you can't basically leave your network. So that's why it's wrong. So I replace that with and answer in red. A management VLAN is any VLAN configured to access management capabilities of a switch. Okay, management VLAN is not used for user traffic, right? So going out to internet or things like that is not related lah, right? You can do management remotely by opening firewall, but again, we're talking about VLAN. So VLAN without routers, which we haven't learned about yet, okay, in connection with VLAN, does not allow traffic to leave the network. Okay, so far we only discussed about traffic within the network, okay, within the LAN. Okay, just that our LAN now composed of virtual LANs, right? Without router, your traffic will stay inside the LAN, cannot go out lah. Right? Okay, Farah?
Okay.
Right? Because internet and cloud means it's outside of your LAN already. So that's why the answer is incorrect lah. Right, so other comments? Okay, so number 7, you can pause there lah, Farah. Right, any questions? All right, guys. Farah, you can go back and try to do the parts in tutorial 1 that you haven't answered, Farah.
Okay.
What about Kelvin and Noel so far? Okay.
Okay, this the questions
Looks
only
okay,
can find from the lecture notes, copy paste only, but afraid when the exam comes, I cannot like find my own words to answer the questions.
Oh yes. I just let you guys know what happening with other DCIT. Luckily, there's none happening, but in other departments, especially in business, there are cases where students copy each other, and why we detected, because it's exactly the same. Some answers are not from the notes exactly the same. Everything is similar, very similar. So
If from note is okay, but if not from note but similar to other people, it's not okay like that.
yeah, not okay. In fact, from notes, exactly from notes also not okay. Not
But
okay.
but not so severe punishment I found out.
No, not severe. That means you just get your marks deducted lah.
Yeah.
Yep. So copy from each other is the one that really bad.
It's really
I
common.
think.
Is it really common?
Right. So I think the best is to try to answer using your own words lah. Okay.
Okay.
I understand. I understand. To rephrase your English must be uh, not very good, but must be capable, right? To rephrase. Sometimes under pressure of time, it's very hard for us lah. But try lah, try practice to find how to rephrase the answer. Okay. Uh, Apart from that, I think I will have to. Yeah, I want to remind you guys. The type of question, not only for the exam but also the test, is more high level. They will give things like this. Like they give you diagrams and they ask you to explain what's happening on the diagram. So in that kind of question, even though you have access to your notes, there's no easy way for you just copy from the notes, right? So the tutorial here, questions like this one, it's just for understanding the concept only. For exam, the question would probably be like the one shown like number 5. Okay, they give you the example, the topology, the scenario, whatever, and then you have to answer based on that. So that one you really need to understand the concept in order to apply it onto that diagram, to that scenario. Only then you can get a correct answer, right? It's not directly can look at the notes lah. Concept maybe concept. So that means understanding the concept is crucial lah. A lot of questions I noticed for computer networks. Okay, it's going to be like that. And during the test later, also the question majority like that lah. Right, less of the explain or less of the this kind of what there will be no true false question basically, right? So I just prepare you guys lah. All right, our next class is on Friday, yeah? Friday, 2 o'clock until 4 o'clock, right? To prepare for that, please install, if you have removed, please install your packet tracer, okay? Because we'll be
Right.
doing the packet tracer exercises, okay? For our, sorry, not Friday, Wednesday, sorry.
Oh, okay.
Wednesday, Wednesday, sorry. Tomorrow, that means 9 o'clock in the morning until 11, the first session. And then maybe we'll have a break, a 1 hour break, and then at 12 to 2 o'clock. All right?
Okay.
Okay.
All right. So, Farah, I'm looking at tutorial 1. Your answer for question 1C. A switch uses its MAC address table and routing table to make forwarding decision. It's only half truth, so it's has to be false, yeah? So a switch has a MAC address table, and a switch uses a MAC address table to make forwarding decision. But it does not have the routing table. Routing table is used by the router, right? So the answer will be false, okay? Because switch does not have a routing table. A router has a routing table, okay? The router is the one that's using routing table to forward packets, whereas a switch uses MAC address table to forward frames, okay?
Oh, okay, okay.
Yeah, okay. Okay, so continue lah, continue the rest of the question. Farah, question 6, huh? Tutorial 1, question 6. Are you looking at it?
Yes.
Yeah, okay. So let me just okay, so this is a switching table, the MAC table, right? So from 0D source, destination 0B. 0B is not in the MAC table, so it will basically it needs to broadcast, right? So the only ports attached to any host, okay, except the ingress. So FA1, FA3, FA5, and FA9,
Oh,
right?
so it goes back to the.
Yeah, it goes to all these 4 ports. So you only highlighted FA3 and FA5. This is correct, but you miss out FA1, FA9.
Okay.
Yeah,
Understand.
because it needs to broadcast because it doesn't know. Excuse me, 0B is not in the MAC table. Therefore, it will broadcast except for the ingress, which is FA7. So it will push out FA1, FA3, FA5, and FA9. Excuse me. I drink water first. Okay, you only miss out the 2, FA1 and FA9.
Okay.
Okay. All right, number 8. Correct answer would be because half duplex means only one type of transmission can happen at one time, either sending or receiving, but not both at the same time. Only full duplex, both send and receive can happen at the same time. So if half duplex, right, means either it's sending or receiving, right? So collision happen when one of the host send and the other one is sending also. So sending, they meet in the middle is collision happen, right? So that's why lah. Okay, fair.
Oh, okay. Noted. Okay.
All right. So last one, number 11. Broadcast domain. Yeah, this is
I
correct.
haven't finished typing.
Okay. But it's correct already. Lah. Broadcast domain extends across all layer 1 or layer 2 device on the LAN. That's correct already. That's correct already.
Oh, okay. I thought
Mm.
need to like explain more on the
Oh, okay. You can add more, right? But this is correct already.
okay. I just type it here lah.
Ah, Noel and Kelvin, you guys can leave if you want to leave already, yeah?
Okay, sir. Thank you, sir.
Yeah.